Okay. Let's see. Open top box with a square base. Let's have a volume of 256. Find dimensions of the box made of the smallest amount of material. Open top box. Okay, so that's kind of what we're dealing with. And volume for a box is typically length times width times height. Or you can also have depth in there. So we'll see what they have. But from the question, we note the base is square. Okay, so base is square. And the box has no top. Let the base sides have length x. When they say the base is square, that means this is x and this is x. And height be y. For this question, we know the volume must be 256 cubic feet. Recalling the equation for the volume of the rectangular box and set it equal to 256, we have the following equation. Volume equals. Now, our length times our width, since the length and the width are the same, we'll have x times x, and our height is y. So volume is equal to x squared y, which is also, they told us, equal to 256. Okay. Now, they tell us that find the dimensions box can be made of the smallest amount of material. Smallest amount of material means minimize. So this down here, since we want to minimize the amount of material using a box, we want to minimize the surface area. So minimize the surface area. Now this is where we have to think about, it's an open box, so I don't have to worry about the top part. But we've got our bottom part here, and now let me draw these out, which is x by x. Surface area, you'd multiply these two together, so this would be x squared. Now, let me think about this. This is y, this is y, and this is y. So this is y by x, this is y by x, this is y by x, y by x. So we're going to have 4 of this next one, which is, oops, I didn't draw that real well, but which is y by x. Well, again, the area, you multiply these together, x times y is xy, so we're going to have 4xy. And then we're going to add those together. And probably, here it is. Area is equal to x squared plus 4xy. Now the problem is we can't have two variables here on the right side. So we need to solve one of these. In this case, I'm working with this equation, and if I divide both sides by x squared, I'm going to have y is equal to 256 over x squared. Now we want to plug that back in here to get rid of this y. So we're going to have a is equal to x squared plus 4x times 256 over x squared. So area is equal to x squared plus, that x cancels one of these, 4 times 256. (1024) over x. I'm going to write that as x squared plus 1024, and I'll take this x, the first power up on top, becomes x to negative 1. Now we want to find our derivative of a with respect to x. So x squared becomes 2x. This one, take my power, put it out in front. So I got minus 1024. Lower my power by 1. So it's going to give us 2x over 1 minus 1024 over x squared. Sorry, I'm getting over a cold. Now I need to get a common denominator, which would be x squared. So I'll multiply top and bottom by x squared here. So I'm going to get 2x to the third over x squared minus 1024 over x squared. Now since they have the same denominator, I can merge together the top parts. So I got 2x to the third minus 1024 over x squared. Now to find our critical values, we set our top equal to 0, and we set our bottom equal to 0. Now the bottom, though, if I solved it, would give me x equals 0, which doesn't make any sense. That would tell us this distance is 0, so we don't need to worry about that one. This one, take the 1024 over, divide both sides by 2, and what do we get? 512. Take cube root of both sides. And does that come out nice? Let's see. Cube root. Math. Cube root. 512. 8. That does come out nice. So I'd be 8. Now this distance, but we also probably need y, and I'll go look at the problem here shortly. So we'd take that x equals 8 and we'd plug it into this equation. So we've got 256 over 8 squared. 256 over 64, 4. 6, 1, yeah, 4. Now let's see exactly what they're asking for. If they're asking for those dimensions, or they want the volume, or surface area, or what. Base is 8, so they got 8 feet by 8, and then the height is 4 feet. So it looks like that's what they wanted on that. Oh, they use second derivative test, but it's perfectly fine doing it the way I did it here. I didn't actually test this. You know, we'd want to do our table here, where this is negative infinity, this is positive infinity. We do our test cases. Pick something between negative infinity and 8, like 0. Something between 8 and infinity, like 10. And plug those in your first derivative, and just make sure that it truly is a whatever we're trying to find, minimum. And if I plugged in 0, where's my derivative at? Derivative is here. X squared is always positive, so the denominator is always positive. If I plugged in 0 here, 0 to the third is 0, times 2 is 0, minus that is negative. So we got a negative over a positive, which is negative. If I plug 10 in, 10 to the third is 1,000, times 2 is 2,000, minus 1,024 is positive. Positive divided by positive is positive, so this is decreasing and this is increasing, so it is indeed a min.